Hello, my name is Amidu Oloso. I work at NASA. I do HPC for science applications, science and engineering applications. This is just a quick overview of an operator that we wrote to augment the functionality of SciDB. Oh, sorry, wrong one. Oh, okay, all right. Well, this is just a quick overview of what SciDB is. I'm sure some people in the audience are familiar with SciDB. It's an array-based database management system that has a rich set of operators to do, simple, arithmetic operations, linear algebra type operations. In our case, we want to have the ability. This is just a chart showing the SciDB setup, the way we have it over there. Okay. Why are we interested in SciDB? Again, to study climate data. And for this specific case, we want to have the ability to, identify events. Okay. Events meaning some kind of activity that spans space and time. Okay. I want to be able to group cells identified together to form this event. So we need something like CCL, connected component labeling. And we have this set of requirements. Okay. For us, it has to be flexible in terms of connectivity, and we want to be able to handle periodic boundary conditions because, again, sometimes we do wrap around the globe. This is just some figures showing how we enforce connectivity. You may wonder, why do you want the connectivity? Sometimes we want to identify cells that span through just time before we go ahead and group together in space and time. Okay, this is just a sample mask array to show where we start from. Okay, some thresholding has been applied. We've identified cells that meet, those that threshold criteria. Okay, then the mask is divided into chunks. Several chunks are actually assigned to each SciDB instance. Okay, in the first step or the first go around, we compute labels for chunks on each instance. Okay, and then we identify boundary labels. Okay, we replicate them across all instances. And then we compute CCL for the boundary labels. And then we propagate back. And the key thing here is to use the original index, which essentially is flattened coordinate for fast access as we go through memory. Okay. This is finally labeling for readability. This is just how to invoke the operator, and this is just showing that we can handle periodic boundary conditions, in this case, in both X and Y. Again, we can have 4-dimensional data, n-dimensional data, for all that we care. Okay, we demonstrated this in 30-year worth of MERA data. MERA is data produced by GEOS5, which is the Goddard Earth Observing System code or model for studying climate and weather. And this is just a demonstration of how the operator is able to capture events. Okay, here we show 2 events that span both space and time. Right? This is the mask, and this is the result from the CCL. Okay, this is basically showing that one of the events ended, the other one continues. Okay, this performance, the key thing is, as we expected, the boundary labeling will not scale. It's dominating, so we are thinking about what to do to improve that. We have good scalability actually in all the other parts, so we're looking at this to see what we can do to improve that further. And even if we're able to get that to scale very well or to improve as much as we want, we don't want to recompute CCL all the time. So we're looking at not recomputing labels that were already computed, right? And I believe that was the last slide. Thank you.